All right, 19.1, essential angles and inscribed angles. So our essential question here is, how can you determine the measure of central angles and inscribed angles of a circle? So a little vocabulary here for us. Investigating central angles and inscribed angles. A blank is a segment whose endpoints lie on a circle. That is a chord, and hopefully you saw a lot of these when you did the vocab worksheet. A blank is an angle with measure less than or equal to 180, whose vertex lies at the center of a circle. And that center hopefully is a key phrase for you. So that is a central angle. And blank is an angle whose vertex lies on a circle and whose sides contain chords of the circle. And so that is our inscribed angle. All right, so the diagram here shows two examples of an inscribed angle and the corresponding central angles. So AB and BD are chords. Then our central angle, let's see on both of these, so AB and BD. And then ACD and ACD are a central angle because the angle touches the outside of the circle, but the vertex is at the center of the circle. And then our inscribed angle is ABD and ABD, because all 3 points are now on the outside of the circle. All right, understanding arc and arc measure. So an arc is a continuous portion of a circle consisting of 2 points called the endpoints of the arc and all the points on the circle between them. So a minor arc is an arc whose points are on or in the interior of a corresponding central angle. So the measure of a minor arc is equal to the measure of the central angle. So there's my central angle, there's my arc. Those would be two equal things. If this was, say, 40 degrees, this one out here would be 40 degrees. Minor is because it's the smaller portion of the circle, as opposed to a major arc is an arc whose endpoints are on or in the exterior of a corresponding central angle. So the measure of a major arc is equal to 360 minus the measure of that central angle. So we said this was 40. So our major arc is this portion out here. So it'd be 360 minus 40, which is 320. So remember, minor is the smaller of the two arcs, and major is the bigger of the two arcs. Okay, continuing on, we also have what is called a semicircle. Is an arc whose endpoints are the endpoints of a diameter. So this one goes straight across there. So a semicircle measure is 180 because it's the diameter. It cuts the circle in half. So if a circle is 360, half of that is 180. Now, an important use from this is the arc addition postulate. So my bigger arc, ADB here, can be made up of AD plus DB, which is helpful as we work on problems here down below. So first one here, if BCD is 18, so that's an angle by that symbol there. So BCD, so that's that right there, is 18. And EF, now this is an arc because of that symbol, And I want to put EF there. I'm going to put 33. We want to find ABD. Now there's a couple things that we can do here. So we know part of ADB, that's this here, because there's our central angle. And so our corresponding arc is the same, so that's 18 degrees. So we just need to find AB. Well, AB, as we look at it, is a vertical angle to EF. So if that's arc is 33, this angle is 33, which means this angle is 33, which means then this arc out here is 33 as well. And then AB plus BD gives us ABD, so we add 33 plus 18, and we get 51 degrees for the measure of ABD. So again, quick, that means angle, and the arc, or little circle over each of these, means the arc of that circle. Okay, let's look at number 2. So number 2, they give us the measure of arc JK is 27 degrees. And that's a typo there, that shouldn't be there. So we want to determine NP, we want that portion right there. Well, again, if this is my arc is 27, that means this angle is also 27. And then since those are vertical angles, I get 27 degrees there, which means my arc here is also 27 degrees. Another big thing they give us here is they tell us that that's a right angle. And since we know that MK is a line, so if that's 90, that side also has to be 90. So we could say that the measure of angle MCP is equal to 90. And we know because of our vertical angles that measure of angle MCN is equal to 27. Well, MCN is that portion, and NCP with that portion, so that plus that has to equal 90. So to get the missing part here, we really have the whole, which is 90 minus 27 equals our missing portion there. And so that gives us 63 degrees. So the measure of arc NP is 63 degrees. All right, so go ahead and try number 3 on your own there. So go and pause the video as you try to work through this one. Now, once you are done, hopefully you came up with a measure of arc BD equals 11 degrees. So you can check your work based on that. Ask any questions you may have when you come in. All right, inscribed angle theorem here. Simply states the measure of an inscribed angle, remember that's an angle that touches all 3 parts to the outer circle, edge of the circle, is equal to half the measure of the intercepted arc. So ADB is half of that arc. So if this arc was, say, 60, ADB then would be 30. Quickly, our angle is half of our. So let's look at an example here. So we have several we want to figure out here. We want to find a couple arcs and then a couple angles based off of that. So first one, we want arc DE. So that's going to be this portion here, and that is inscribed by that angle there. And so going back, so our angle so the measure of angle EAD is equal to half of the arc DE. Well, we know our angle, so that's 54, and that's 1/2 the arc. So then to solve, we just multiply both sides by 2. That drops that out, and we get 108 equals the measure of arc DE. Now, many of you will get to the point where you won't have to write all of those out like that, but it doesn't hurt to write out the equation just to simplify what you're thinking through. All right, so we have arc DE is 108. So label that over here. That'll help us some. And now continuing on, we want arc BD. So that's going to be slightly confusing the way they word it, because BD could be that way or that way. Now, generally when it's 2 letters, that is the shorter route of the 2 that you'll take. But when there's multiple cases, often that would be written as arc BED, so we know specifically which way to go. You never get in trouble for having more letters to describe specifically which way you're going as opposed to less. So then if we want BED going that direction, it's just arc addition. So we have 18 plus 108. So then we say the measure of arc B, now I'm going to write it as ED, is 108 plus 18, which is 126. Then we want DAB, the angle this time, not the arc. So DAB, which is now encompassing arc BED. So since the arc is 126, the measure of the angle is going to be half of that. So half of 126 is going to be 63 degrees. And then last one is we want ADE, the angle. So ADE. Now this one, as we look at it, you're like, well, we know we have 18 over here, but we don't know that, and how do we figure all that out? One of the important things we need to remember is pay attention to the arc that we're covering here. So as we see the arc between AE, it's created by that line that goes through the center, which we call a diameter. So then we'd have a semicircle. So this arc is 180 degrees, which then would mean that the measure of angle ADE of that semicircle arc is going to be 1/2 of 180, which is 90 degrees. All right, your turn. Try a couple problems there. So pause here as you work through this number 5. So checking your work here, the first one, measure of arc WX, is going to be 18 degrees. And then the measure of arc XZ, which is this top portion there, it's going to be 162 degrees. And the measure of the corresponding angle, measure of angle XWZ, is the inscribed of XZ, so that's going to be 81 degrees. And then our last measure of angle WXZ is equal to 90 degrees. All right, and last theorem here, inscribed angle of a diameter theorem. The endpoints of a diameter lie on an inscribed angle if and only if the inscribed angle is a right angle. So as we look here, we have our diameter. There's our endpoints. And so since the inscribed of a diameter, that's half of a semicircle, which is 180 degrees, which is 90 degrees. So that angle forms a right angle, which therefore also forms a right triangle. Just something to keep in mind as you work through some problems. Hey, essential question, how can you determine the measure of central angles and inscribed angles of a circle? So remember, central angles, using the symbol there, are equal to the arc that they cover. And then inscribed angles are equal to 1/2 the arc that they cover.